Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Harvard College, University of Delhi. So in this series of our operating system concept, in our previous lectures we have seen the components of operating system, and we have covered 4 components of operating system as in process management module, input output management module, file management module and network management module. And in today's lecture, we will be going with the rest of the components of operating system, which are 4 components are here, and all those 4 components we will be taking up in this lecture. So with this background, let me begin with the first component for today. Here is the main memory management. Now first thing, when we talk about main memory management in terms of operating system components, here the main memory is actually what we are referring to is our random access memory, which is actually a large array of words of bytes, and this every word or byte is having its own address. Basically, why this main memory is required? Because a CPU, if going to execute anything, or input output devices are going to process anything, so basically that is they are going to take that particular data, or they are going to keep their output data onto the main memory itself. So basically we can say it is a repository of quickly accessible data which is shared by CPU as well as for by input output devices also. So main memory, or as in we can say random access memory, basically a volatile storage. That's what I told you, that here we will be talking about random access memory whenever we are referring main memory. So it is a volatile storage. That means it's going to lose its contents in case of any system failure or as soon as the power goes down. Now what is the main motivation behind memory management? It is actually we need to maximize memory utilization on the computer system. Why? Because memory is, we can say, it's a crucial resource. In the earlier times of computers, the memory was a very costly resource. Thankfully, this is not the situation nowadays, but still we need to maximize the utilization of memory, and in this situation we need the memory management module of operating system. Now what all tasks this memory management module is going to perform is, it is going to keep track of which parts of memory are currently being used by which particular process, and what is the requirement submitted by those process. Then it need to decide which processes to load when memory space become available, because there will be too many processes in case of a multi-programming and multitasking situation. There will be processes which we can say which will be in the waiting line, and they want themselves to be loaded into the memory space. So basically it crucially involves allocation and deallocation of memory to the processes or to the programs as and when needed. So all these activities, which is keeping track of memory's usage, then which processes to decide, which processes to load, that decision, and apart from that allocation and deallocation of memory space. All these activities comes under the purview of, we can say, memory management module. Now apart from memory management module, there is one more there is one upcoming module which is secondary storage management. Now why these are 2 different modules? Because one is memory, another one is secondary storage. So memory, as I told you, that whenever I am talking about memory management, I am talking about random access memory. But apart from random access memory, operating system is also, I can say, managing the secondary storage, which is the disk storage. Now why? Because programs are brought into, or processes are brought into main memory during the execution, but you know that main memory is small as compared to the hard disk. So, it is not going to accommodate all the data and all the programs. So, some data and programs are to be kept onto the hard disk or any other storage device, and these will be loaded into main memory according to policy that when it is to be loaded and which one is to be loaded. So, we can say computer system is providing secondary storage, once to back up the memory, and another one is main memory is too small, so backup is requirement, and another one is that main memory is not going to accommodate or not going to store the data or the programs permanently. It is a volatile storage. So, secondary storage as provided is non-volatile, and we can say quite more in terms of capacity as compared to main memory. So, the operating system module also needs to manage the secondary storage, and there is a separate module for this, which is known as secondary storage management module. Now, if you see the system architecture or policies described, we can see most of the modern computer system, they use the disk as the main online storage mediums for both program and data, but CPU and input devices are not going to access that particular data and programs which are stored onto the hard disk. They will be taking the data which is available on the main memory, but most of the programs like compilers, assemblers, sorting routines, editor, formatters, these are also stored onto the disk initially until they are loaded into the memory. So, basically we can say why this secondary storage management module is important, because this secondary storage which is your disk, is going to be used both as the source as well as of the destination of the processing. It will take some data and programs for the processing, load them into the memory, whatever kind of output is there, that is also being stored inside the hard disk permanently. So, because of these things, operating system is having a separate module of this secondary storage management, and this is better known as secondary storage management module. Now, what will be the activities in connection with disk management which are performed by this secondary storage management module? So, one is the management of free space, another one is the storage allocation, and third one is the disk scheduling. So, when we talk about free space management, there can be space inside the hard disk, but it is scattered, or I can say it is in the fragments. All those fragments needed to be collected at some point of time, which is better known as disk defragmenter. So, in this way that free space has to be managed, or free space if freed by the program and not garbage collection is not done by the application, then operating system is there to collect the garbage and free the whole space. Apart from that, which particular file is going to be stored and where, because files when once created, finally they are going to stored onto the disk, and the index file allocation table, which is more commonly known as FAT, will serve as the index of this listing of the files. So, all those management regarding to storage allocation is also done by this operating system, secondary storage management or disk storage management module. Apart from that, it is going to one more very important activity, which is known as disk scheduling. So, disk scheduling basically says that which particular file will be stored into the disk, which particular file will be taken up from the disk, and how are you going to access those modules. So, that all comes under the disk scheduling. So, here we have seen the operating secondary storage management module and memory management module, and these two modules are, we can say, attached or connected with the storage management. So apart from this process, input output, file, network and storage management, which we have already seen, we have couple of more modules, and those modules, one of them is very important, which is security management component or security management module of operating system. So why do we need this security management module? Let us first try to understand the need of this module, and then we will go through what are the tasks or the features of this module. So in a very not very complex, but in a very normal system, there will be various processes which needs to be protected from each other activities if they don't have any shared resources in between, or even if they have any shared resources, except from that particular resource, these processes are not supposed to interfere in each other's execution. So these needs to be protected from each other's activities. Then why this is important? Because this may create conflict in usage of resources. So basically the security management module or operating system needs to ensure that these processes have proper authorization of the particular resource which they are claiming or which they are using. Now these resources could be files, memory segments or memory areas, separate memory areas we can say. Then they have CPU as a resource because CPU cycles are used for the execution, and many other such resources which are required by the processes. So operating system needs to ensure that these processes have gained proper authorization for all these resources, and then only they are allowed to use these resources. So this is the task, or this is the we can say profile of the security management module of operating system. So with this with a lot in order to perform all these tasks, this operating system module of your security management, it needs to access the control of control the access of programs, not only programs but any program which is running in the memory, that is the process. And apart from process, it also needs to control the access of users who are allowed to access particular resource in using some primitives will be allowed to do so only. They are not allowed to breach in for the other resources. So users which are going to access the resources, that access has to be controlled. So users to the resources defined by a computer, controls to be imposed, and not only the imposition of the control, but it needs some means of the enforcement also. Now let me give you here an example. For example, we have some memory addressing hardware. So that ensures that a process can only execute within its own address space. So that memory kind of security or memory addressing hardware ensures that a process can only execute within its own address space. That means this process is not allowed to breach in the area of other processes. So basically this type of all these mechanism for controlling the access of programs comes under the purview of security management module. Now apart from this, we also need the timer ensure that no process can gain control of the CPU without relinquishing it. Otherwise, it is going to be a complete chaos with the system. We are going to ensure that the operating system is going to control that for what amount of time which particular process is going to gain control of CPU, and this all is going to be decided by the policy. So basically these are the policy decisions. Finally, with the security thing, we also need to ensure that no process is allowed to do its own input output. Each and every input output is to be routed through the interface of operating system, and this particular security management module is also there to protect the integrity of various peripheral devices. So, for how much time which process is going to gain the access of which particular resource, which user is going to gain what access, and no process is allowed to do its own input output, and also to maintain the integrity of the various peripheral devices is also the responsibility of this security management component. Apart from this security management component and the components which are related to storage management, namely secondary storage management and memory management also, we have one more component of the operating system which is related to command interpreter system. So, basically let us try to understand first that what actually this command interpreter is. We can say this is the primary interface between the user and rest of the system. So, basically a command interpreter system executes a user command by calling one or more number of underlying system programs or system calls. So, basically what I am trying to say here is, let us take an example. For example, we have given a command either through command line interface or through graphical user interface. The user has given a command to, let us say, create a file. So, now that create a file will be executed or will be accomplished with the help of some system calls which are underlying, and these system calls will be executed when you say create a file. So, there will be different system programs or different system calls corresponding to the user commands. So, the command interpreter system or the command interpreter's components executes a user command by calling one or more number of underlying system programs or system calls. These system programs or system calls are needed to be called in order to execute a particular user command which is given by a user, and this is the task of the command interpreter system. So, now this command interpreter system allows human users to interact with the operating system and provides convenient operating environment to the user, because if each and every user, let us take an assumption that each and every user is operating without this command interpreter system, and the interaction is done directly by the user with the hardware or with the internal level components, then it is going to be a very chaotic scene. So, operating system is there to save here, which provides convenient programming environment to the user through this command interpreter system, and many commands are given to the operating system by various control statements. Corresponding to these control statements or corresponding to these commands, we can say we have underlying system calls, and the task of command interpreter system module is to call those system calls, get those system calls executed whenever there is a command given by the user. So, basically we can say what kind of data or what is that entity that is going to take the execution charge. So, basically we can say a program which reads and interprets control statement is going to be executed, is going to be automatically executed. So, program which is there to read and which is there to understand or interpret various control statements is automatically executed, and that program, that component of the operating system is called the shell. And what are the examples of shell? Windows DOS we have, then the command window of the DOS to be very specific, then we have command window of the Windows operating system. Then we have C shell in case of Unix or Linux, or then we have bash in case of Unix and Linux also. So command window of Windows and DOS, bash of Unix and Linux, and C shell of Unix and Linux are the shells, and these are the shells which are the program which reads and interprets the control statements, and these are automatically executed when your operating system is being we can say loaded inside the memory at the time of booting. So with this device management, disk device management or secondary storage device management, memory management, then we have which is your security management, and also the management of command interpreter system and other fours which we have seen in the previous lectures. These 8 responsibilities, or these 8 component comprises of a general operating system. We can always add more onto it in order to have a more complex software, or in order to have a more complex operating system. But with these 8 responsibilities, or with these 8 modules responsible for various tasks, the operating system is not only that, it is having other responsibilities also, because it is a pretty complex system and various activities are performed by the operating system. Now, what kind of other responsibilities I am talking about? So, within that other responsibility we have security. Now, what is the difference between this security and the security management, which we have already covered? So, here that security was kind of related to internal levels. So, here in this situation, when we talk about security as an extra added responsibility, so that is ensuring the prevention of unauthorized access to programs and data, and how it is done with the means of password and other similar techniques. So you have seen that whenever we log in into a secure system, or whenever we switch on a secure system, it will ask for the various we can say login names and credentials. So there is an added security layer. So basically ensuring the security or preventing the unauthorized access to programs and data by means of password and other similar techniques comes under this added responsibility of security, which is different from the security management which we have already gone through. Then we have control over the system performance as an added responsibility. So basically your operating system is also responsible for recording the delays between the request for a service and the response from the system. This statistics is also maintained by operating system, that whenever a service is being requested, whenever that demand has been fulfilled, what is the delay between these two situations, and so on and so forth. So basically in order to monitor the system performance, or monitoring the system performance is also the responsibility of operating system. Also in case of multiple jobs, or in case of multiple users, your operating system also needs to keep a track of time and resources which are used by various jobs and various users. Now why this accounting is required? This accounting is actually required in order to for the statistical purpose of, we can say, billing or charging the users for using various resources, or maybe for the research purposes in order to improve the performance. So this job accounting is also one important component or one important module. Then not only the these things, but error detection is also a very, very important responsibility of operating system, one of the operating system modules. So basically production of dumps or garbage collection, as I was talking about, if your operating system if your application is not doing it. Then we have various traces, maintaining various logs, various error messages, and other debugging and error detecting aids are also kind of executed or also implemented with the help of operating system modules. Not only this, but also we need coordination between various softwares and users, like coordination and assignments of compilers, interpreters, assemblers and other software to the various users of computer system is also one component of OS, which presses or which forces about the coordination, which needs the coordination between various softwares, which are housekeeping software or many others, and various users. So apart from these apart from these components, your operating system is also having the added responsibility of maintaining the external security, control over system performance, of the job accounting thing, of error detecting, providing the error detecting aids, and also the maintenance of coordination between other software and users. So let us quickly recap this lecture. In this talk we have seen the four remaining components of operating system, and the four were covered in the earlier lectures. Apart from that, we have also seen the extra added responsibilities taken by operating system through its various components, and here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed the lecture. Thank you.